Hello, welcome to the class of 7905. This video is a supplementary video that I captured trying to explain the section table contained in the PE file structure. In last evening's class, one of the students asked a question about the section table. This video, I try to explain it in more details, and I try to give you some kind of proof that one error that I find in the binary called BinText. Let me repeat the slide on the PE file structure of the section table. For example, the BinText does have 4 section table. Each section table should be 40 bytes. It comes with the structure of section name 8 character and then virtual size 4 byte, virtual address 4 byte, and size of raw data 4 byte, data to raw data 4 byte, characteristic 16 byte. Our concern is much on the section name, virtual size, virtual address, and size of raw material. In this slide, I try to give you some idea about the virtual address and the relative virtual address. To avoid hard coding memory address, that is the virtual address, in the PE file, usually the linker or the compiler, when create the binary after getting the bytecode, it creates a PE file. Inside the PE file, all the address is used as RVA, relative virtual address. It representation of some displacement or what we call the offset from the original sync, the first byte of the PE section or PE data relative to the start or base of the binary inside the memory. RVA is an offset in the process memory. VA simply equal to image space plus RVA. I've told you many times, most of the PE file, the image space is set to 0040000 for a Windows 32-bit Windows environment. In the screen, I show you one of the section table used by the CFF Explorer. When you click in here, you will find all the relationship and the data structure right there. And one section that is data structure for the virtual size, which is I claim it as the actual size of the data chunk, is D10. But the raw size, which is the size of the data on the disk, the minimum unit is 200, that is equal to 512 byte. And if we calculate this, when we compare the other section, all the raw size should be bigger than the virtual size because the alignment, any empty space should be filtered with 0. But in one exception, we find the data structure in this section, the size is D10, which much more higher than the assigned raw size 200. If that data structure contained in this data section table is really containing D10, it will overflow the next section table size. Then I claim it is an error. But how come the errors exist? And in the class, student asked me a question. What if the window internal structure contained inside controlled by the window loader? If window loader read everything here, that the program should have a problem. So I do some additional calculation. I want to show you right now, you see my desktop. And the desktop showing uh, some of my work, including a calculator, a hexadecimal calculator. So when we go back to the slide right here, you will see that the raw size, that is the image size offset starting the first byte of the data section table is at 5800. So if we use 5800 plus D10, here I'm using the calculator to show you. It will go to the address of 6510. However, the next section is only located at the 5800, which is representing the difference of only 200. That means the minimum file alignment size of 512 byte. If we are really using the 1D0 and the actual, here I use 1D0 as an illustrated example. I make an assumption. Something wrong with the linker, and if the linker put the D1D0 instead of D10, the size is 59CF, which is still okay because it is lower than the 5800. So the meaningful data range of the 5800, which is goes to 5930, still under control because 5930 does not exceed 5800. In that case, I want to do an actual experiment. If we make change of D10 into 1D0 or 130, in that case, if I make modification of the binary, I want to see whether I can start the program or not. So what we are going to do is try to locate the iData section in the header location of the PE file. And we use PE Bear that I highly recommend you to download it and try it. We can find it the location of the section table of .data is exact locate between in the offset of 240 to 267, where the actual size value of D10 is actually located at the offset of 248 to 249. With lead till ending, it shows 10 OD. You need to swap the OD in front of 10. It comes to D10. So using a tool, which is called File Insight, it comes with the hex editor function as well as be able to analyze the PE file structure. I install the program and load up one instance of BinText, and then go to 248 and edit the 2 byte from D001 from the value of the 10 OD to D001 so that I can get the result of 1D0, or I try to another version, change it into from 10OD to 1003, and then try to save the binary using the PE bear to check again, see whether I can change from the value of D10 into into 130. Then if I can kickstart the process, I hope it works. Right now, I'm going to switch my desktop to my virtual machine. Okay, we are on the virtual machine. First of all, I need to find out where is the file inside. Our TA already put the all necessary, most of the tool that we require inside our tools folder. I go to basic and then find the file inside, and let me install it. You just accept all defaults. After everything is finished, make sure you have the launch file inside. I want it to be launched. Let me minimize it. And then let me drag an additional version of the BinText to the desktop. Copy to the desktop. Here I have two BinText on desktop. One is a shortcut. One is the newly created BinText file. First, let me drag the BinText to the PE bear. If you don't have PE bear, try to install it, or you can use some other tool to check this. Okay, let me go to PE bear of the shortcut version of BinText. We go to the section headers and we click the section header lower pane. Now you can clearly see there are four sections in the section table. Starting from size of 400 on raw size means the record offset calculated using the PE file on the hard disk, which is the file. So you see 400, 3800, because 400 adding with the raw size of 3600, it goes into 3800. In the data section, clearly we can find that it starts at the offset on 5800 in the file. Of course, in the virtual memory should be start at 700. Then 5800, and then adding, assuming the next section is 200, that add up 5800. But the virtual size is D10 showing right here. We cannot see D10 or 3432 or 1D68 or 31868 because that is assumed the actual size of the data. So you will see that 400, 3600 is greater than 3432. 1E00 is greater than 1D68. 3200 is greater than 3168. But this is an exception. 200 cannot exceeding D10. Okay, let me try to find where it is located. If I click right here, you will see that on the PE file, it starts from the offset of 240 and record everything, including the content of .data, as well as 100D, which is using Lithuanian, that is D10. I need to change the byte set on 240 plus 8, that's 248 and 249. Okay, so Right now, let me close down this section. And I'm not using the shortcut. I want to make some editing on the newly copied bin text by using File Insight. I start the File Insight, go to Desktop, find the bin text version with .exe, which is not the shortcut. Okay, let me rearrange my desktop. File Insight do not provide us any similar allocation GUI interface, just like PEBear. I go to search, that is small button right here called Go To. I click Go To, make sure I take starting from the beginning, and then I want to do a check what is the actual data size, meaningful data size, starting from 5800. That is data section data contain. So I type O0, 0x5800. Okay, that is the data of the data section. If I'm moving forward to 5800, that is the beginning of next data set. The length is only 2000. And you will see that after 5931, all this data to the 5800 is marked as 0. It's nothing right there. So how about I make change of the offset 248 to 249 into 1003. That means I want to change the value of the virtual size from 1D0 into 310. See what I can do. So I go back to the go to search go to button. I don't pick the relative or absolute, whatever. I start from the beginning. I go to 0248. It gives me the location of 10OD. So now I need to change from OD to O3. Here, I already make change. Then I save a copy of this binary. It will overwrite the original bin text. Now I put the bin text newly created bin text file. I put it in the PEBear to make a double check. So this time I'm using the .exe version instead of the shortcut. Okay, that is good. Right now we changed from D10 into 310. It's still greater than the 200. Can it work? You see that? It works. What is the reason? What is the window loader doing? Does the window loader check this virtual size? I'm not sure. Okay, before that, we have made some change on the virtual size value at the offset of 248 to 249 of the bintext.exe. We demonstrate if we change from the Z10 into a lower size of 310, then it will still working. Now, I want to demonstrate another version. I change to D10 into 1D0 by editing 248 to 249 into the value of D001. Okay, We go back to our virtual machine. I go to Tool, Basic, find the BinText, make a copy, and paste on my desktop. When I put it into PEVAR, go to the section, you will see that D10, I want to change in 1D0. But PEVAR do not allow me to have that kind of function to edit. I need to use file insight. I call up file insight, try to load the BinText on desktop with the extension exe. I go to search function, go to beginning, see if I can use absolute address 0x248. It gives me 10OD. Okay, what I have to do is change into D001. 01 D0. D001. I only change 248, 249. I go to save it. It will overwritten the newly created BinText.exe. Put this edited BinText.exe and go back. You will see that I changed it 1D0, not exceeding 200. Then kickstart the program. You see that it worked perfectly. So it seems the window loader doesn't care